Here's a discussion question about defining functions. What would this function do? What kind of input does it take? What output will it give? And what's a reasonable name? Here's the function. Def f. F is not a reasonable name because it doesn't describe what this function does. You'll have to read the body to figure out what it does, and then we'll come up with a better name. I suggest you pause, think about it yourself. We'll go over the details in 3, 2, 1. Let's look at what happens to s, which is the value that gets passed in. S gets divided by the sum of s. So s must be the kind of thing that you could take the sum of. That means it's an array. When you take an array, compute the sum, and then divide s by the sum, you're dividing each element in that array by the sum. This expression here would then give you the proportion of the whole for each element in s. Multiplying by 100 gives you a percentage, and rounding to 2 decimal places gives you a percentage that's rounded. So I would have called this function percents instead of just f. Typically, the best way to define a function correctly is to just start writing the body not inside of a function, but just inside of a cell in your notebook. So let's start with an example. I've got an array of 1 and 2 and 3. If I want to turn those into percents, then I need the total, which is the sum of the counts. Then I can take the counts and divide by the total. Okay, so far I have proportions, not percentages. I would have to multiply by 100 to get percentages. And as we can see, there are long decimal expansions here. The purpose of np.round is to limit the number of decimals to at most 2. Once I have a working example, I don't keep the input, but instead the manipulations, and I make them part of a function body. So percents takes in something, how about some counts? And what does it do? It computes the total, and then it returns the result of rounding the proportions multiplied by 100. Now, not only can I take percents on the original counts, I can also take percents on anything I want. 1 and 1 and 1 and 1 gives me 25% over and over again. None of these calls to percents are changing their input. Instead, they're computing something new. So counts is still 1, 2, 3 because I defined it up here. Just because I use the same name as the argument name here in the function doesn't affect counts out here on the outside. And by the way, I didn't need to call this counts. I could have called it anything I want, as long as I'm consistent throughout, and then I can still take percents of counts defined here, or percents of this new array, and counts is still 1, 2, 3. However, if I tried to take percents of the number 2, I would get an error. A type error arises when somewhere in your expression that you've evaluated, you've used the wrong kind of value. Int object is not iterable. It's not a very helpful message, but it does show you where it happens, and that's quite helpful. What it's showing you is that since you called percents, it tried to do whatever you described in the body of the percents function that we defined. And one of those lines here with this arrow is total equals sum of s. I tried to take the sum of the number 2, and the number 2 doesn't have a sum because it's not an array and it's not a list. Now I'll just make a few more comments about functions and how flexible they are. If you have a function that looks like this, it's often worthwhile to describe it not just by giving it a useful name, but also giving it a sentence description. The conventional way in Python to do that is to write one or more lines enclosed in these triple quotes. Those triple quotes start at the first triple quote and end at the last triple quote, so you can write whatever you want in here. For example, I could write convert the counts to percents out of the total. And what counts am I talking about? Well, it is helpful to use descriptive names for your argument values so that it's easier to figure out what's going on in your function body and so that you can relate to it in the description above. Now this description doesn't change what percents does. Percents of counts is still the same. It's just there to help people understand what will happen if they call percents on some other array, and it helps interpret the result. Now you can define percents on multiple arguments if you want. For example, I could add in decimal places to indicate how many decimal places I want to round to. And instead of always rounding to 2 decimal places, I would round to the number of decimal places specified. I can't call percent counts anymore because percents takes 2 different arguments, one called decimal places. If I say, please round to 4 decimal places, then it will do exactly that, 1, 2, 3, 4. If I had said only 1 decimal place, then it will give me this shorter version. Now it might be the case that you sometimes want to use this second argument and sometimes you don't. One way to handle that is to use a default argument value. That's something placed in the first line of the def that tells Python what to do if the second argument is left out. So I can still provide it. I can say it's 1 or it's 4, and it will behave accordingly. But if I delete it entirely, then it's going to use the default argument value that was specified when the function was defined in the first place. So I can use the default sometimes, I can use a specific value some other times, and both will work. That's the point of these default argument values, which have an equals right after a name and before some value. Now when you call a function, you can either call it with positional arguments separated by commas, or by specifying which argument you're filling in. I could have written decimal places equals 1, which specifies that I want to set this particular argument to 1. I get the same behavior either way, and we've seen examples of this, for example, when we were sorting the rows of a table by a particular column, we would say descending equals false, and that was setting a particular argument to the sort function and doing it by name instead of by position, which just helps keep track of what you're doing when you make a function call. If you're ever curious what a function does, you can call help on that function, and what you'll see is whatever's written here. This is called the docstring of the function, and it's a description that appears here when we define it and also appears again when anyone asks for help. Convert the counts 2% out of the total. And here I notice that I spelled 2 wrong, so if I run it again, then it'll be fixed.